All right, I'm going to do a little bit of intro for this next kind of applied problem, and then I'll do 2 videos with examples. So it'll be 3 videos that kind of go together. Okay, so this next problem, kinds of problems that we're talking about are called work problems. That means things like 2 people painting a room, or 2 people cleaning a room, cleaning it up, picking it up, mowing the lawn, washing the dishes, things like that. 2 people painting a chair, whatever. 2 printers printing out something at the same time. All those kinds of things, work problems. It could also mean work problems are things like filling up a swimming pool or emptying a swimming pool or those kinds of things. Something that several of you may not know is the word vat. That's used quite often. Vat is a great, big, giant soup pot. Basically the kind of pot that, say, somebody like Campbell's Soup, the company, would use to make their soup in, a pot that would take up a whole room. So a vat is a huge, huge pot that you cook something in. I think that's one word that comes up all the time that people aren't sure of. So kind of like distance problems, work problems have a formula too, and it's rate times time equals 1 job accomplished. Okay? But one thing we need to know about this, a person's rate or their speed, how fast they do a job, is always written as 1 over their time. So if you look at rate times time equals 1 job accomplished, if we want rate, we have to divide this by t. So let me do it this way. We have to divide this by t to get rate by itself, and we get rate equals 1 over time. So remember, in our table, when we're putting this together, somebody's rate is always 1 over their time. And the other thing to remember is in our equations, it always, always, always equals 1. 1 job accomplished. Okay? Now, when we create our equations for these kinds of problems, okay, if we are working with people, okay, our equation is always person 1 plus person 2 equals the 1 job accomplished. It's always that's how the equation is set up. If we are working with things, okay, if those things are doing the same thing, then it's always thing 1 plus thing 2 equals 1 job accomplished. If those things are doing opposite things, so one thing is putting water in and the other thing is taking water out, opposite things, then it's always thing 1 minus thing 2 equals 1 job accomplished. You know, always 1 job accomplished, okay? If we have something like a vat that's being filled up, or a swimming pool that's being filled up, or something, okay? We've got, let's say, water going in, and we've got water going out. Okay, something can fill it up, something can drain it out. Okay, if our thing, our vat or our swimming pool or whatever, our sink is empty, to begin with. Okay, then, and remember, these are doing opposite things, so it's thing 1 and thing 2. So this would be in minus out equals 1 job accomplished. But let's look at it if it was the same idea. We've got something filling it up and something draining it out. In, out. But this time it's full to begin with. It starts off full. Well, that means we can't put anything in until we take some stuff out. But this is still things doing opposite things. So now we have to start with out and then subtract in, and it equals 1 job accomplished. So take these notes or print this out if that's possible. These are things that you need to know in order to do these next applied problems that I'm going to do 2 videos for, give you 2 examples of work problems.